Hi everyone. So I'm recording this video to help solve the questions we have. The questions, the quiz we're supposed to use for this quiz, question 1 and 2 in this week's slide. So I will share my screen now, and so I can just solve it, just to give you guys some more breadth, more understanding into what it is about, and then to be easier for you to solve on your own. So this is the question. So the question 1 is a preliminary investment estimate of an entire project is 140,000. For the period of 3 years after the completion of the project, maintenance cost is estimated to be 40,000 per year, and the benefit or the savings from this particular deliverable of the project is expected to be 200,000 per year. So we have investment, 0th year. We have other costs, maintenance, that would actually happen for the first 3 years, 40,000 each. Then we also have savings for the first 3 years as well, too, of 200,000. So now let's compute the NPV for this. Before we do, let's state what we have. So we have I is our investment amount, is 140,000. Then we're given that we have a cost. Let's say that is S or C, which let's just call it full cost, is 40,000 for 3 years, or 40,000 each for 3 years, 40,000 for 3 years each. And then we also have the savings, which is 200,000 for 3 years as well, 3 years each, for 3 years. Or for each year for 3 years, let's say each year for 3 years. So let's take this one away. That sounds like a better English. Okay, so basically the same thing. Okay, then we have that our discount rate, or the rate of return here, K, is equal to 8 divided by 100. So it's in percentage, so we'll convert it to the fraction, appropriate fraction for that. And then we have the period T to be 3. So it's 3. So let's try and draw a table to get this done. So let's say we have the year here. So this is 0 year, 1, 2, and 3, right? Okay. So for that, we have the investment, which occurred only in the 0th year. That is the year the project was completed, or the year the project was executed or planned to be executed. And then we also have other costs associated with the deliverable from this project, and that would be 40,000 each for the 3 years. So it's 40,000 for 3 years. And then we have the savings. So the savings is the benefit from this project, and it's 200,000 for the 3 years as well too. Okay, so this is what we have. Let's say this is a column called sum. Let's name the column sum. So we're going to add everything up together. So this is a negative amount because it's a sunk cost, not sunk, rather, it's an investment cost. So it's an expenditure that has to be done. And so are these maintenance, they're also expenditures. So they are outflows appropriately. Then the savings are inflows. So the first thing to do is to do the time value of money for these sets of cash. We can do lots of ways to do it, But a safer way to do it would be, we can add these things together and do the sum here, or we can just add these ones and do the net present values at the end. So let's go the other way. First of all, let's look for the present value of the costs. So to get that done, we would say remember our equation is equal to, or maybe let's just state it here. So to compute the net present value of an investment, which in this instance is a project, we say it's equal to I, which is the investment itself, the project estimated amount or cost, plus a sum of all the savings, or in this instance, the cost from the project brought to a base year of the present value of for them. So that will be 1. To do that, 1 plus K, which is the discount rate, raised to power T. So that's the expression to calculate the NPV. So now let's do this other part where we are looking at, okay, this is supposed to be, there's a sum here, good. So let's do the present value for this set of cash flows, that's this cost, and then we'll do a present value for this set of cash inflows. So these are outflows and the inflows. So for the outflows, we'll have that using this equation, we'll have that it will be equal to the present value, which is the cost rather, divided by 1 plus K, which is 0.08, raised to power the period. For the first period, for the first item here, year 1, it is 1. Good. So because everything else would change, but except K, that is constant, let's fix K constant. And now let's drag this. So when we double click on this, you see that it says that E21, which is 40,000, divided by 1 plus E16 here, raised to power E19, 2. So that shows we're good, right? Same thing here as well too. So we can sum it up there by saying sum into this plus that. Great. Then let's do the present value for the savings. So this will be 200,000, so it's equal to the P, 200,000 divided by 1 plus 0.8, right? Raised to power 1. Enter. So again, the only thing not changing is our rate of return. So we'll fix that. And then we'll drag this. Right. So for the 3 years, the sum of that will be this 3 item. Therefore, the project NPV, the NPV for this project, using this our expression, will be equal to this negative investment plus this cost, so some of them brought to the present value, and this savings are brought to the present value. Right. If you wanted to verify this with Excel, what we'll just do will be to say equal to this amount plus, let's open a bracket. Let's open a double bracket. This amount plus NPV okay. The rate is 0.08. The value is this first one, right? Enter. Good, go ahead. No, we haven't closed it, so we're going to add another one again now. So plus NPV plus click on this. 08 at 200,000. Yeah. It's the same thing with this one. I hope that's not too complex for us to understand. I'll show you guys. But what I've done is to do the NPVs for these cash flows together, but I could have done them independently. So in other words, I could have said, for example, I do the NPV for the cost, which is 0.08. So here I highlight all of the costs and I just press enter. Okay. Then I come do the same thing for the savings, so equal to NPV for the savings. So that I do 0.08, and here I highlight the savings and press enter. Then I come add them all together. That's the NPV will be equal to this plus that plus that. So costs are negative, inflows are positive. Costs, investment are outflows, and therefore they are negative. So that's the NPV for the first question. So for question 2, this is question 1. Oops. Question 2. So for, question 2, question 1. So for question 2, it's pretty straightforward. Question 2, it's pretty much like we've done before. So we have for the question 2, our investment is 50,000, right? And it says that there's no cost here. The savings or the benefits from this project, or the earnings, like it said here, are 50, 60, 50,000 for the first year, for year 1. This is for year 1. Yeah. So for year 2 is 60,000. Year 2. And then for year 3 is 70,000. So this is pretty straightforward. So the way we still do, we do the same way. Just put year 0, 1, 2, and 3. Right. So 1, 2. Then I have investment here, which is 50,000. And then I have the savings, which comes at the end of the first year at 50,000. At the end of the second year, projected is 60,000. Savings, estimated savings at the end of the third year would be 70,000. So just those. So to NPV, like we said, will be, this is negative because again, this is a cost, is an outflow to execute the project. And these are inflows and therefore they are positive. So the NPV will be the present values of each individual amount summed up and then added to the investment. So in other words, NPV will be like we've done before, equal to this amount, right? Plus the present values of this amount, which we can calculate by saying P, which is this, divided by 1 plus 1 plus k, which is also 0.8 like it was for the past question. So 0.8 raised to power 1, right? Okay. So I'm going to just put a bracket here to that. Plus, bracket open, 60 divided by, bracket open again, 1 plus C16 raised to power 2, bracket close, plus 70 divided by 1 plus C16 raised to power 3. That's the amount. Now, so let's verify this if we did well. So we can either do two things. We can just do it straight up so we can see it all. So I just do the net present values of this amount, present values. So let me just call this PV savings. So that will be equal to this amount, like we did before, divided by 1 plus, right? That's K raised to power T, which is 1 here. So I can fix this. C16 is constant, so I'm going to fix that. And then I'll just drag this one. So if I sum this amount, the net present value for this expression actually is this amount. That's what it gives me. And so for the project, the net present value for the project, therefore, will be equal to this plus that. You can also compare, use your Excel as well to your NPV formula to do it. So that's it. And so I'm going to share both this Excel with the work now and this video on Moodle for you guys to enjoy. And if you have any questions still after doing it, you can ask me, but I'm sure it should be pretty clear right now. Thank you.